Hello, today we're going to be covering section 7.3, thermal inversion. Basically, the learning objective here is to describe what a thermal inversion is, which is inverted thermal, and its relationship to pollution. You'll be able to for your FRQs, you'll be looking at visual representations generally and relate them to environmental issues. The urban heat island effect tend to be in areas that have higher surface area and air temperature than the surrounding suburban areas. It's due to lower albedo. In other words, the concrete and asphalt absorb the solar energy as opposed to reflecting it. If you have more vegetation, the sunlight is going to be given off as infrared radiation, which is heat. So the sunlight comes down, hits the buildings, reflects up as opposed to being absorbed. So you can see it's reflecting up much, much more rapidly than what it does over here in the rural and suburban areas. There's a less evapotranspiration. In other words, less evaporation due to trees. Why? Because there aren't any. The water evaporating from surface and transpiration from plants carries heat from the surface into the atmosphere. This cools off the rural and suburban areas which have more vegetation, whereas the urban areas are going to get hotter. And so what happens is we're going to get more clouds in this area, whereas this just gets clouder. So with the thermal inversion, what happens? Normally the atmosphere is warmest at the Earth's surface and cools as altitude rises. So it's warmest here, then gets cooler as we get higher up. It makes sense because sunlight comes down, is absorbed, reflected, goes back up as colored lights. Because warm air rises, air convection carries the air pollutants away from the Earth's surface and distributes them higher in the atmosphere. So because it's warm down here, it's going to rise and pull the pollution up higher under normal circumstances. So it goes here, goes up under normal circumstances. However, during a thermal inversion, a cooler air mass becomes trapped near the Earth's surface, inverting the normal gradient. This is due to a warm front moving in, or it could be due to hot urban surfaces cooling overnight while infrared radiation absorbed during the day is still being released. And so what's happening is it's cooler down towards the surface and warmer up above. Because cold air at the surface is trapped beneath the warm air mass, the convection currents can't carry the pollutants up and away. So the pollutants that are down here can't get away. And so this is the effects of a thermal inversion. We've seen this. Air pollutants such as smog, particulate matter, ozone, sulfur oxides, NOx are trapped closer to the Earth. Respiratory irritation, the asthma flare-up leading to hospitalization, worsened chronic obstructive pulmonary disease, and emphysema. Decreased, who wants to come here and visit this when it looks like this? Decreased photosynthesis because the light can't get down to the plants. So the practice FRQ for this is, can you explain what the arrows in each diagram illustrate upon the impacts of a temperature inversion on air pollutants such as smog? Hopefully that was helpful. Thank you.